All right, guys, now let's take a look at that second part of chapter 15. So we finished up with talking about the different blood types, or not blood types, I'm sorry, the different components of blood, and then we were looking at, what each of those parts did. In this section, I want to take a look at blood types. So let me show you what I mean by that. Let me go ahead and get this slideshow started here. Okay, so here we're going to look at, in the second part, we're looking at we'll real briefly look at the steps of hemostasis. I think in hemostasis, I may have cut this PowerPoint up a little bit, may have skipped through that. The major thing we're going to talk about here are the 4 blood types, and I'll talk to you guys about what RH factor is and how that's part of blood types. So what happens in hemostasis? Hemostasis, again, is the prevention of blood loss. So we do see the platelets, as we talked about in the previous section, but we have what's called vascular spasm. What happens is blood vessels can recognize when there has been some type of damage, and they will almost constrict in different portions, and that almost will kind of prevent that blood from being lost, but at the same time move things like white blood cells and things and platelets to the site to try and get those tools to the site to prevent that blood loss from happening. So vascular spasm will take place, but also the platelets will move to the site to provide a platelet plug. So here comes platelets moving towards that injured vessel, and will just start to gather at that site to try and, again, to stop blood from exiting. And then coagulation is just a clumping of the blood there to try, again, to stop at that site. That's what we're seeing is, as I mentioned, that blood clot is very similar to a coagulation. So that's just kind of a synonym there. So that shows the coagulation. Again, your textbook gets into a little bit more specifics with the involvement of different plasma proteins like prothrombin and how that's converted to then fibrinogen. And fibrinogen will then form these fibrin threads, which kind of forms like a mesh-like thing that will stop all those blood cells from exiting. So when you see that, that's what that means. But you guys, I skipped that on the PowerPoint. I already cut that out, so you guys don't have to worry anything about that. As long as you guys know that platelets are what's forming that clot there. But that's what's involved in that process of hemostasis. As I mentioned earlier, that anticoagulants, we do have a natural anticoagulant in our system called heparin. Those basophils are going to help with that. So we have natural mechanisms that prevent that formation of a clot. The endothelium itself, which is the inner lining of our blood vessels, which we'll discuss in a couple chapters when we start talking about arteries and veins, but the inner lining of those blood vessels is designed to prevent things from being trapped there. It's a very smooth inner lining, so it's going to stop. It's, again, the way that that's designed is to make sure that nothing can gather there to cause any clots from happening. And again, the secretion of heparin, like I said, is an anticoagulant and is a very natural anticoagulant that will stop the clotting from happening randomly in our bloodstream. Then we have different anticoagulant medications, as I mentioned in the previous section too, that we have people that sometimes suffer from heart diseases or perhaps have had clots before, and so they take blood thinners. So there are different anticoagulant medications, like I said, Coumadin and warfarin are prime examples of those. And that's what we're seeing here on the next slide. So there are anticoagulants. Heparin is an antithrombin that's going to stop that clot from happening. Coumadin, as I mentioned, is going to also be an anticoagulant. You do not need to worry about exactly how they stop the clotting. Like I said, we skipped this part in that process of hemostasis, so you all didn't need to know thrombin and prothrombin and the involvement of those plasma proteins. But heparin and Coumadin are anticoagulants. We also have different clot buster drugs, which are, if there are clots that are formed randomly before they actually cause a blockage in our blood vessel, we do have drugs that are going to, kind of break that up to make sure that doesn't stop blood from getting to these different tissue sites. So the tissue plasminogen activator, or TPA, that particular type of drug is given to patients who maybe are experiencing a blood clot, and we need to break that up. And that's what's going to get into the bloodstream and cause that to happen. Okay, so let's get into our blood typing then. So blood types. Everybody has a different blood type, and this is very, very important for in donating of blood, or in the event that there's some type of accident, there needs to be a blood transfusion, meaning I have been maybe in a car accident and I'm rushed to the hospital and I've lost a lot of blood. There are blood storages at the hospital where they can just take that and give it to me, and because my blood, if I've lost so much, I need to replace that very quickly. Otherwise, again, all of my tissues are being deprived of oxygen, and that could lead to death. So in the event that this happens, where I need a transfusion, they need to make sure that they are giving me the right type of blood, since everybody has a different blood type. There are 4 different types of blood. We have type A, type B, type AB, and type O. In the next couple slides, we'll define this, and I'll even show you a picture to show you what this means. And there's a picture in your textbook too. So type A, we're named based on the type of antigen that we have on the surface of our red blood cells. Individuals who are type A have what's called the A antigen. Most of the time, antigen, when you hear the term antigen, it means something foreign in our body. But this is the case where antigen means something that belongs. Those that are type A, again, the type A antigen belongs in their blood. They also have what's called the anti-B antibodies in their plasma. What that means is, because, for instance, I am type A, I'm specifically type A negative, and I'll get into what negative and positive means. But I'm type A, so that means I normally have the A antigen on the surface of my red blood cells. I also have what's called the anti-B antibody. Antibodies are what fights off different infections and different invaders in our blood. So what would happen if somebody gave me type B in a blood transfusion? Well, because I have the anti-B antibodies in my plasma, those antibodies are going to see that B antigen and fight it off, and what's going to happen is it's going to cause a coagulation, a clumping, and that is going to be a very serious problem as blood tries to make its way through my body. So that's what I mean by those antibodies. So type A, the A antigen belongs. So that is not considered foreign, it needs to be there. The B antigen is foreign, so that's why we have those anti-B antibodies. In people who are type B, they're named type B because they have the B antigen on their red blood cells, and they cannot be given type A because they have anti-A antibodies in their plasma. Type AB is named that way because they have both. They have both A and B antigens on the surface of their red blood cell. Because they have both, they don't have any antibodies. They see A and B as things that belong, so they both belong. So neither one of them will be fought off in the event of being a transfusion. And type O, they are named type O because they don't have either the A or B antigen on the surface of their red blood cell, but they do have, so because neither one of them are on the surface of their red blood cell, they do see both A and B as foreign, and therefore they have these anti-A and anti-B antibodies on their plasma. So let me show you something. So this picture, not a great picture. I didn't realize it was kind of blurry, and I, of course, don't have my textbook with me. There is a picture in your all's text, and I'm sorry I don't have it with me at this time. That's very, very similar to this, that shows kind of a visual example of what I mean. This picture is from a different book, but I liked the way that this shows this. They show these little circles representing the A antigen, these little spikes representing the B antigen. Again, we're named according to what we have of those 2 types of antigens on the surface of our red blood cells. So if taken a blood sample and they test my blood, they see that, oh, she has the A antigen on the surface of her red blood cell, but she doesn't have any B antigens. Therefore, she's type A. That's what I mean by that. So this individual you can see is type A. This person just has these little spikes, which we see as type B. So therefore they are, or which is the B antigen. So therefore they are type B. Since this person has both those little circles and the spikes, they have both A and B antigens, and so therefore they would be named as AB. And since this person, you can see, has no antigens on the surface of their red blood cells at all, they are considered type O. So that's where the names come from, is based on the presence of, or absence, presence or absence of these A and B antigens. Where the antibodies come in, that importance is, again, in the event of who can give to who. Again, if I were to ask you on a test, just based on the name, if I said that an individual has the B antigen on the surface of their red blood cell, but they do not have the A antigen, what type are they? You guys would tell me type B, because they have the B antigen, not the A. If I said that an individual has both A and B antigens on the surface of their red blood cell, they are what type? Well, because they have both, they are type AB. They're named according to that. So that's where the name comes from. Like I said, though, the antibodies that are important here are responsible for defending in the event that we're given the wrong type. Because, again, those that see the A antigen as something good, B is something that doesn't belong. So that's kind of a way to think about this, is based on what's on our red blood cell, anything else would be considered foreign. So to somebody who is type A, the B antigen would be considered foreign, and that's why they have the anti-B antibody. Opposite in somebody who's type B. In somebody who's type B, the A antigen is now considered foreign. In somebody who already has both, they both belong, so therefore they're not going to fight off either A or B because they both are normally there. So nothing is foreign in that case. So that's why you see neither A or B antibodies. And then in type O, nothing is recognized. So A and B are both considered foreign because neither A or B antigen is naturally on the surface of their red blood cell, so they're considered both invaders. So that's why they have the anti-A and anti-B antibodies. Those that are type A, because they have, those that are type AB are ones that are considered the universal recipient. Anybody who is type AB can typically receive blood from anybody, and here's why. If I'm type AB and I am needing a blood transfusion, could I receive blood from somebody who is type A? So look up here at type A. Notice they have the A antigens. If I try to give that to type AB, that would be okay, because somebody who is type AB already sees the A antigen as something that's good and something that belongs, so therefore they're not going to fight off that A antigen. Same thing with receiving blood from somebody who is type B. They too also see the B antigen as something that is good, and so because of that, they're not going to fight it off. They could also receive from type O because somebody who is type O doesn't have any antigens at all, so therefore there's nothing foreign at all on the presence of their, or on the surface of their red blood cells. So that's why type AB are considered the universal recipients. And that is why type O, those guys are considered the universal donors. They're called the universal donors because notice that because type O has no antigens on the surface of their red blood cells, in the event that that is given to any of these other blood types, those blood types aren't going to fight anything off because there's nothing present to fight off. So type O are the universal donors. And so we'll discuss that as we continue moving forward here. So the antigen-antibody interaction. Blood will actually clot or clump up in response to interactions between antigens and antibodies. In an example of a mismatched transfusion, so we've talked about this a little bit already, if a type A recipient has A antigens on their red blood cell and anti-B antibodies on their plasma, the type B donor has the B antigen on their red blood cell, as we've seen. So the result is, if, say, type B is the donor, type B, meaning that type B is given or injected into somebody who is type A, like myself, then what happens is my anti-B antibodies are going to start attacking that donor's antigens, the red blood cells, because I see that B antigen is something that doesn't belong in my body. I start attacking it, causing agglutination, which means a clumping, and hemolysis, which is destruction of blood cells. So it's going to just start killing off these blood cells and really could eventually cause that clumping and then cut off of blood supply to my tissue. So it can lead to a lot of problems. As I mentioned, type O is the universal donor. Type O, again, has no antigens on their red blood cells, so therefore they can be given to anybody. Anti-A and anti-B antibodies of all other blood types have no antigen to attack. So that's why they're considered the universal donor. So type O can be safely donated to anyone. Type AB, as I mentioned, is the universal recipient. Type AB, since they have neither anti-A or anti-B antibodies in their plasma, they don't have anything to attack. They see both A and B antigens as something that's good, so they welcome that into the bloodstream. So any type, A, B, AB, or O, can be given to type AB. We'll get into the specifics of that, though, because it is going to depend on the then second part of the naming of our blood types. The second part, the name that we're usually given is type something, but then it's positive or negative. And that is based on the presence of another type of antigen. It's called the RH factor. If you also have the RH factor on your red blood cell, you are considered positive. It's just, like I said, it's just another marker that's on the surface of your red blood cell. It's called the RH factor because it was found in a specific type of monkey that starts with an RH. So that's where that comes from, that specific name. But again, it's just another antigen. So if you have this additional antigen, you are considered positive. So given an example, say if I have an individual who has the B antigen on the surface of their red blood cells, but not the A, but they also have the RH antigen. They are what blood type? They're B positive. Again, positive because of the presence of that RH. People who are without this RH antigen, that's where the negative comes in. So if they don't have that particular antigen at all, they are type negative. So if I asked you on a test, if I said an individual has both A and B antigens on the surface of their red blood cell, but they do not have the RH factor, what blood type are they? Well, they would be AB for the two antigens that are there, but then negative because they're absent of the RH factor. If I said that an individual has neither A or B antigen, nor do they have the RH factor, what blood type would they be considered? They would be considered O negative because neither A or B means they're type O. And if they don't have the RH, then they're negative. So that's where that comes from. So RH negative people usually do not have antibodies. They don't have any anti-RH antibodies in their blood, but they develop them after exposure to the RH factor. So right away, if maybe unintentionally somebody with A negative blood was given A positive blood, it may not cause a reaction right away, but after that initial exposure, now it's recognizing that positive or that RH factor and may then eventually develop some problems with it. And so some of you guys might be familiar with this causing some problems in pregnant women, and we'll get into that. So same thing goes for, as we talked about with the A and B system, that's very important in blood transfusions. People with type negative blood don't recognize the RH factor, and therefore they cannot receive positive blood because they see that as something that is considered foreign. So RH negative blood can be donated to RH positive recipients, because in the event that somebody who is, say, B positive, if they are given B negative blood, that's okay. They're still receiving B blood, so again, nothing to fight off there. If they're already B positive, that means that they have the RH factor, so that's present, that's good. If they're receiving B negative blood, there's no additional antigen to fight off, so they can receive either B positive or B negative, and they'd be okay. but somebody who is B negative cannot receive blood that's B positive. Makes sense on that? It's just it's another antigen. Now that individual who is B negative, again, doesn't normally see that Rh factor, but then when introduced to the bloodstream, they see that as something foreign and it will start to attack it. So that's the second bullet point there, that Rh positive blood cannot be donated to Rh negative because, again, of that, again, the foreign aspect of that, and it would start to fight it off. So truly, I mentioned before that the universal donor was type O, but it's truly type O negative. Type O negative because, again, type O negative can be given to anyone, whether they're positive or negative. And the true universal recipient would actually be AB positive. Because, again, AB negative individuals would not be able to receive positive blood. But AB positive individuals can receive either positive or negative. So the true universal recipient is AB positive. So this is what I was just getting ready to talk to you guys about with some of you guys that may have heard of this. You guys may have heard of Erythroblastosis Fetalis. Rh incompatibility during pregnancy can sometimes cause this to happen. What happens is if a mother is type negative blood, whether they're A negative, B negative, AB negative, or O negative, and the baby's father is positive, that means that the baby does have potential to be type positive themselves because they may have received that genetic outcome from the father. What happens is in late pregnancy, the Rh positive blood will then be transferred from the mother or from the baby to the mother. Because again, in pregnancy, a fetus and a mother will share blood. So the mother will actually start to develop anti-Rh antibodies, recognizes that as something that is foreign. The mother's anti-Rh antibodies will move into the baby, then almost fighting off that baby because the mother's blood sees that as something foreign in that situation. So it causes that agglutination, which again is clumping, and hemolysis, so the killing off of those red blood cells, and eventually can lead to the killing off of that fetus. So there are ways to prevent this. Some of you guys maybe who have had children maybe recognize the RhoGAM shot, or there are shots that are given to women in that circumstance. For this reason, that we don't want this to happen, so it prevents that fighting off of that type negative, of that type positive blood. So that shows what's happening here in Erythroblastosis Fetalis, that again, in the event that the fetus is type positive and the mother is type negative, is the only time that this happens. If the mother is type positive, this is not anything to worry about. But in type negative, if the fetus is positive, then again, the mother will start developing antibodies in response to this positive blood that she's now seeing for the first time, and will start to fight off that blood that's being shared between the mother and the fetus. Okay. All right, guys, and that is it for chapter 15. So that concludes that lesson on blood. We will talk a little bit more about blood in a later chapter. So, continue moving forward in your videos as we'll get into the different types of blood vessels. But we'll first talk about chapter 16, which is your next video, as we get into the anatomy of the heart. All right, guys, if you have any questions, let me know.